In this video, you will learn about nonlinear systems of equations and inequalities. So, keeping in mind that we have already discussed lines, parabolas, circles, ellipses, and hyperbolas, when we look at the equation, how do we know which one it is? Well, in general, a line, of course, has no squared terms. A parabola, opening right, left, up, or down, is only going to have one squared term. Circles are going to have two squared terms. They're going to be the same sign and have the same coefficient. Ellipses are going to have two squared terms with the same sign but different coefficients. And hyperbolas are going to have two squared terms with different signs, one positive and one negative. So we're going to use the same techniques that we used previously, substitution and elimination, to solve these systems. So for this first example, I like to think of it first as identifying what this is. And I am hoping that you can see that this is a circle. It has a center of 0, 0, and a radius of 5. So I'm going to go ahead and sketch that. Here, 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 and here. And I'll do my best to draw a good circle. All right. Now, the second one, I'm hoping you can recognize this as a line. And if we solve for y, we get y equals 3/4 x. So it's going to go through the origin, up 3 and over 4, and we're going to get this line here. Now, my graph's not perfect, but you can see that we cross in two different places. So this way I know I'm looking for two different solutions, two ordered pairs. So what I'm going to do now is I'm going to take this y equals 3/4 x, and I'm actually going to plug it in to the other equation for y. So I'm going to get x squared plus 3/4x squared equals 25. Now I have an equation only in x's, and I should be able to solve it. So this is 9x squared over 16 equals 25. If I clear my fractions and multiply by 16, I'm going to have 16x squared plus 9x squared equals 400. 25x squared equals 400. So x squared equals, I believe, 16. So x is plus or minus 4. Remember that when we take a square root, we have to take both the positive and the negative. Now, if we look at our graph, we can see that these are x coordinates. This is at 4, and this is at minus 4, and we need to find their corresponding y coordinates. So we will plug those back in here. If I use the positive 4, I'll get y equals 3. And if I use the y equals negative 4, or x equals negative 4, I'll get negative 3. And so we've solved for those two solutions. So I have a couple other equations here. Here we have the same circle actually, center 0, 0, radius of 5, and I'll draw that. Only this time the second equation, notice it only has one squared term. I'm going to write it as minus x squared plus 6, is a parabola. It opens down and is shifted up 6 units. So that's going to be, let's see if we can find our x-intercepts. So we would let y equal 0. Oops, let's take that off. So we'll have 0 equals minus x squared plus 6. X squared equals 6. And if I take the square root, I get x equals plus or minus root 6. And so just for graphing, just so that I have an idea of what that is, it's about 2.44. So we'll put it here and here, and that helps me kind of graph here. So how many solutions do we think we're going to get here? Well, I see 4 different places. 1, 2, 3, and 4. So when we're done, we should have 4 solutions. Let's take a look. I am going to take this expression here, and I'm going to solve for x squared. So I'm going to say, I'll do y minus 6 equals minus x squared. So I'll get x squared equals 6 minus y. So now, in place of the x squared, I can put 6 minus y. So I'll have 6 minus y plus y squared equals 25. And in descending order, and I'm subtracting 25, y squared minus y minus 19 equals 0. Excuse me. So I'm going to use the quadratic formula to solve that. I'll do it down here because I'm running out of room. So y equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get, simplifying and finding decimal approximations, 4.9 and negative 3.88. So I am going to now take these values here, and I'm going to use them to find the y values. So I know if I plug it into this second equation, I'm sorry, these are y values. We're looking for the x values. So if I plug 4.9 in, I'll get 6 minus x squared. And I'll also get negative 3.88 equals 6 minus x squared. And so subtracting 6 on the first one, we're going to have positive x squared equals positive 1.1, and x is approximately plus 1.04. And on the other side, we'll do the same thing. We'll have x squared equals 9.88, and x is plus or minus the square root. Oh, I already did the square root, so let me just take that off. Plus or minus 3.14. So you can see now I have 4 ordered pairs. Let's write these up here. And based on our picture, these look pretty good. Let's do another one. So on this next one, we notice that we have both x squares and y squareds in both. The first one here is a circle, and the second one here is a hyperbola. So we would have x squared over 9 minus y squared over 9 equals 1. So I'm going to sketch those. Pause your video and see if you can do that. So I think you can see from the picture that we're only going to have 2 solutions, and I can solve this one by elimination. So if I add these together, these 2 equations, I'll get 2x squared equals 18. My y squares add to 0. X squared equals 9, and x equals plus or minus 3. And if I use that 3 into the circle, you'll notice that I'll get 9 plus y squared equals 9. And that doesn't matter if I use the positive 3 or the negative 3, and I get y squared equals 0. So my two solutions are 3, 0, and negative 3, 0. So here is one for you to try. Just so we're clear, this is a circle, and this is an ellipse. Pause your video and see if you can graph it and find the solutions. And you can use elimination in this case. Okay, I think you can see from the picture that these do not intersect, but let's look at what happens algebraically. So I've multiplied our first equation by negative 16, and when I add these two equations together, I notice I get negative 7y squared equals 208. And that will give me y squared equals negative 208 over 7. And we know that y squared, because it's squared, can't be negative, and so this would have no solution. So let's turn our attention now to some nonlinear systems of inequalities. I have a couple of examples of those. So they are similar, however, we have to solve these using graphing. So let's take a look at the first one. We're going to first just look at y equals x plus 4, and we know that that's going to be go through 4 with a slope of 1. And because this actual inequality is a greater than symbol, I don't really want a solid line. I don't want it to be equal. I want it to be greater, so I am going to draw this as a dashed line. So we're not including the line, but we're including everything up until the line. The next thing that I do is I test some point on one side of the line. So what this does really is this line separates the plane or the graph into two separate areas, above the line and below the line. And what we want to know is which side of the line is the true side. So it's very simple to test 0, 0 in most cases. The only time that you can't is if your graph goes through 0, 0. And if I plug that into the inequality, is 0 greater than 4? In other words, is this point right here a true point? And the answer is no. So this is the false side of the line, which makes this the true side of the line. So I'm going to shade this side of the line. I do the exact same thing for the second piece. I start with y is equal to 3x minus 1. So it's going to have a y-intercept of negative 1. And it's going to have a slope of 3. So up 3 over 1, up 3 over 1, up 3 over 1. And this one has the equal to bar in the original. So we are going to make this one solid because points on the line are going to make it equal. Oh, that's the most terrible line I've ever drawn. Let's try that again. Oh, much better. Okay, so now we're going to test a point. Let's test 0, 0. And if I plug that into my inequality, is 0 less than or equal to negative 1? Is 0 less than negative 1? The answer is no. This is false, so this point right here is on the false side of the line. So the other side of the line is the true side of the line. And we actually get that our solution set is where those overlap. So including the blue line, not including the red line. And there's no other way to solve this because there's an infinite number of solutions. The only way that we can represent those solutions is with a graph. So let's take a look at a couple more. Actually, I think I just have. So we have y is greater than x squared plus 7x plus 12. So I'm going to start with the equation. and I'm going to factor it. And I notice that this factors as x plus 3 and x plus 4. So my x-intercepts are negative 3 and negative 4. So negative 3 and negative 4. And let's also find, we know that it's a parabola, let's also find the vertex. So the vertex is going to be negative b over 2a, so it's going to be negative 3.5. And if I plug the negative 3.5 into the equation, I will get negative 0.25, so really small right here. So I'm just going to sketch this. It's not going to be perfect. It's narrow. Okay, again, we need to decide, keeping in mind this goes on forever, are the values inside the parabola going to make it true, or the values outside? So let's test 0, 0 again. We only choose 0, 0 because it's easy to plug in. Is 0 greater than 12? That's false. So this point right here is a false point, which means all of this in here are true points. Okay, the next piece. Oh, I made a mistake. Can anybody see what the mistake is? I didn't make this line dashed. So let's see if I can go through and make this dashed. And why is it dashed? Because the inequality is greater than. All right, so let's see. The next one is just a less than, so it will also be dashed. I'm going to make my note there so I remember. And then it's just y equals x plus 2. So here we are at 2 up 1 over 1. And we'll draw that line. And we want to know which side of that line. Wait a minute, I got to go through and make it dashed. It's easier to do it when you just draw it, but I have this little erase tool. Okay, so it's a dashed line, and then we're going to choose, let's test 0, 0 for this one. And that's going to give us 0 is less than 2. That's true. So we're going to shade this side of the line because the 0, 0 point here was true. And you'll notice that these do not intersect ever, so this will be no solution. That concludes this video.